So let us try to understand another algorithm designing technique, which is backtracking. We have seen greedy, divide and conquer. We have seen dynamic programming, branch and bound approaches. Now backtracking comes into picture when we are having a problem which is not solvable using greedy or divide and conquer, and even dynamic programming is not working. So what should we do? Now generally whenever you enter a maze, भूल भुलैया तो देखी है ना सबने? All of you seen a maze? Yes, no? Now supposedly I am just building a,
Yes, ma'am.
so supposedly I'm building a sample maze over here. I'm just trying to build a maze. So what is happening in this case is the point that I was trying to make, that within the maze there are certain options which are available and certain options are not available. So you have to find a way from the start to the end. So what do? You enter the maze, you explore all the possible paths, and you keep trying. Now you reach a path, there is no more possible path, that is a dead end. When you reach a dead end, what you do? You come back till where you can explore more options, and you continue doing the same process till you reach the final end. Yes?
Yes, ma'am.
So what you are actually doing is you are doing backtracking. You are coming back. You are tracking your route from where you were going. You are backtracking the same route till you have other options to follow. So yes, I am doing that there. So algorithms that are using intelligent backtracking, or they backtrack intelligently, those are called as backtracking algorithms. So they backtrack the same route that has been followed with some intelligence. So those are called as backtracking algorithms. Let us try to solve the recursive maze algorithm using backtracking. The very first example that we are considering today is recursive maze algorithm. What is happening in a recursive way algorithm? Now we can move in 4 directions. We can move north, south, east or west. There are 4 directions in which we can make a move. Now this is a maze. All of you know how to create a maze. How do I represent the maze in the terms of computer science? So to be able to represent this maze or implement this in the form of a data structure, we create a double dimensional matrix. Say
2D array.
Yes,
मैम थोड़ा सा लैग हो रहा है वीडियो में.
So we are going to make a 2D array. So if I'm going to take a 2D array, just take with a simple example. So I'm creating a 2D matrix in which I want to create a root. So I'm trying to create certain roots. Supposedly I'm creating this matrix. So this is a matrix, cell matrix I'm creating, where cell x, y, matrix ka x comma y, this represents 1, implies this is a wall, 0 implies there is a path. Clear? अगर 1 है तो wall है और 0 है तो that means there is a path. What we have to do is we have to find a way from the start to the end. Start से लेके end तक का path हमें निकालना है. Now this is a 2D matrix. All of you can see that. How do I begin in terms of computer science? Now all of you can clearly find that, ma'am, this is the route that we can see from start to end. Visible route? Yes? Can all of you see the route clearly?
Yes,
How
ma'am.
I can represent the maze. Now, when I'm going to build a recursive algorithm, first of all, I want to make sure that at no point of time am I going to fall out of the maze. So if I'm reaching a point, I should come back into the maze. So what I do, step 1 here is to create a boundary. So we are moving on here with now recursive maze algorithm where this is my cell matrix, and the first step that I'm doing is creating a boundary for the given cell matrix. Maze ke liye I'm creating a boundary. How do I create a boundary? I add 2 rows and 2 columns with all ones. 1 means there is a wall. So I'm creating a boundary on the matrix. So this is the extra boundary that I have created. All of you have seen Harry Potter movies.
Yes, ma'am.
तो उसमें वो there was a movie na Goblet of Fire in which there was a maze that they had to complete. So what happens is first of all they enter an area where there is a starting point of the maze, and from that area they have to begin and reach the end. They cannot come out of these walls on their own. You recall? Yes.
Yes, ma'am.
So a similar kind of boundary we have added so that क्योंकि recursive algorithm है, in case we are reaching a boundary area, we should not fall out of here. We should reach a wall and we should go back. Then only backtracking could be possible recursively. So the second step is we start moving from the start position. We start moving from the start position. Now, how do I move from the start position? I see. Now, this is my start position. Since boundary does not have a start, this is my start position over here. Since this is 0. Now, when I'm starting with this position, I check left, up, right and down. North, south, east, west is possible. Kahin pe possibility hai? Yes, there is a possibility. When there is a possibility, I will move in that direction. That is what I will be doing. Yes or no?
Yes, ma'am.
Yes,
And
ma'am.
whenever I am moving in a direction, I will keep storing the direction in which I am moving. So I come to the next cell. When I reach here, there is only again one possible option. I will move to that direction. Now here there are two possible options. I can either move to right or move to left depending on the algorithm. Supposingly you are going downwards. Now after going downwards, there is no other option. Previous option जहाँ से आए वहाँ पे ही जा सकते हैं. उसके अलावा all three options are blocked. That means this is a dead end. Are you understanding that this is a dead end? Yes.
Yes, ma'am.
When this
Yes,
is a
ma'am.
dead end, what you do is you go back to from where you were coming. That is the backtracking part. And when you are going back, I do not want to be stuck indefinitely in the maze. So my algorithm should be able to intelligently backtrack. What is intelligence? When I am backtracking, that means this is a dead end. This is not a valid path. So I will make this 0 into a 1. So that I know that there is no path here. Dobara is path pe nahi aana. We have explored this. Understanding?
Yes, ma'am.
Yes, ma'am.
Then I come back to this 0. Now here I am coming from, so only available option is moving to the right. So I move to right. Again, only option is moving to right. Now either I can go downwards or I can go rightwards. Supposedly I am going downwards. Again, only downwards is possible. Now again I am stuck. There is a dead end. Since once again I have reached a dead end, I will backtrack my solution. Now I am backtracking. Here also there is no other option. कोई और path possible ही नहीं है. Make this as 1 while backtracking. Then again go here, no more path possible. Again backtrack. Again close this path while backtracking. Now you have come here. Now there are other options possible. Explore the other option. You go to exploring the other option. Here again 2 options are there. Supposedly you go up. When you're going up, then again you reach a dead end. Again backtrack, replacing this 0 with a 1. Now you come here. Now the only possibility is going right. So you will be going right. Only possibility is going down, and you have finally reached the destination and you have found this path using the backtracking. Is it clear how are we doing this algorithm?
Yes,
Yes,
ma'am.
class. So if you reach a dead end, backtrack while replacing zeros with ones. And you have to repeat this process. Repeat step 3 till you reach end. End cell जो भी है, you have to reach that particular cell. So the final cell matrix, जरूरी नहीं है कि इसमें सिर्फ जीरो जो है वो पाथ ही हो, यहाँ पे भी कोई जीरो हो सकता था जो अनडिस्कवर्ड पाथ पे हो, बट नाउ यू हैव अ path with the correct arrows that you are having. Zeros पे जहाँ पे arrows है, you have found a path using the backtracking algorithm. So the recursive maze algorithm is clear to all of you. Anybody any doubt may please ask. Next kind of a problem that we are trying to solve with backtracking is Hamiltonian cycle problem. Now what do I mean by Hamiltonian cycle problem? Supposedly I am
मैम
having a
अगर ये
graph,
मेरे प्रॉब्लम पे क्वेश्चन आया तो कैसे आएगा?
having a sample graph with some connectivity. So supposedly there's connectivity. So there are certain edges which are connected. Now, what do you mean by a Hamiltonian cycle is? Hamiltonian cycle, I'm talking about an undirected graph essentially over here. Hamiltonian cycle is only a simple cycle which is connecting all the vertices in the graph. A simple cycle covering all nodes in the graph. That is called as a Hamiltonian cycle. Now, how do I find a Hamiltonian cycle? There might be a Hamiltonian cycle. There might not be any Hamiltonian cycle in a graph. How do I find such a cycle? So to be able to find such a cycle, if I try, I go from A, I will check what are the possible routes. Then B, check the routes, and so on, go on till checking all the possible routes. So if I check all the possible options, then I have to check considering this edge, बाकी सारी edges को दोबारा consider करना पड़ेगा, so on and so forth. So this problem is an exponential problem. Yes? Yes?
Yes, ma'am.
I do not want to go exponential, so I use backtracking. A backtracking में what am I doing? I am again creating state space tree. You recall state space tree हमने कल create करा था branch and bound में. Similar kind of state space tree I'm trying to create. What do I mean by state space tree over here? Now I will be representing the graph in the form of a tree. State space tree में I am only considering, supposedly I am beginning with some nodes, since all the nodes are included in the Hamiltonian cycle, I can begin with any node. Supposedly I go in lexicological order, that means alphabetic order में A B C D E F करके ही pick कर रहे हैं हम. अगर हम किसी नोड से दूसरे नोड पे भी जा रहे हैं और multiple options हैं, in that case also we will be picking a node with first alphabetical order first. So supposedly A is my root. So I begin with A as my root node. ठीक है? Now I have three possible edges from A going to B, C and D. So this is a node B, node C, node D. Now when I'm drawing these edges, these simply mean I am choosing B is selected in my answer. Now if B is not selected, then I will go for this path. If C is not selected, then I will go for this path. Understanding? This edge means B has been included. This edge means B is excluded. बाकी दोनों ऑप्शंस देखें. फर्स्ट एज मींस बी इंक्लूडेड. फर्स्ट एज के बाद वाली सारी एजेस में बी इज नॉट इंक्लूडेड. सेकंड एज मींस सी इज इंक्लूडेड. उसके बाद वाली सारी में सी इज नॉट इंक्लूडेड. क्लियर? यस. सो आफ्टर दिस बी, अब बी से ऑप्शन है सी एंड ई. आई विल ओनली गो टू द अनकवर्ड ऑप्शंस. So the uncovered options I am having from B, there are two uncovered options available, C and E. Similarly from C, there will be uncovered options will be B, D and E. C से अगर हम जाएंगे तो possible options हो जाएंगे B, D और E. ये clear हो रहा है सबको? Yes or no?
Yes, ma'am.
So sorry, B is not possible.
Yes,
B को हम check कर चुके हैं. B is not possible. D and E are possible. स्टेट स्पेस डायग्राम में अगर बी इंक्लूड होता तो वो यहाँ आ चुका. अब हम जब यहाँ जा रहे हैं, दैट मींस इस पाथ में बी इंक्लूडेड नहीं है, वो हम चेक कर चुके हैं. ठीक है? सो प्लीज, माय मिस्टेक. बी इज नॉट पॉसिबल. डी एंड ई आर फर्दर पॉसिबल. सिमिलरली डी से अगर हमें देखना होता तो ई एंड एफ वर पॉसिबल. सो ई एंड एफ आर स्टिल पॉसिबल ओवर हियर. This is how I can keep constructing. I will not be constructing in the breadth first search manner as drawn. We will be constructing the tree in the depth first search manner. जैसे मेज में जाते हैं ना, एक के बाद एक के बाद एक के बाद एक चलते गए, डेड एंड मिला तब बैक ट्रैक करा. Same thing we will be doing. Can I erase this and start constructing the tree? Tree समझ आ गया कैसे ड्रॉ हो रहा है? Leftmost edge means I am including the next node. उसकी next edge means कि that particular node include B और ये दोनों है excluding B. Excluding B में include C or not include C. Clear? Let us try to now build the graph or straight space tree. So after the root, since I can select B, C, D, but since I am choosing alphabetically, so I select B. Now from B, I can choose C or E. Again, alphabetically, I am choosing C. From C, I can choose D and E. Alphabetically, I am choosing D. From D, I can choose E and F. Now, alphabetically, I am choosing E. And from E, only a single unvisited node is left, which is F. So, I am visiting F. After F, there are no unvisited nodes left. और मुझे वापस कहाँ जाना है? Since I am looking for a Hamiltonian cycle, I have to reach back to A. There is no path from F to A. So, this is a dead end. ये समझ आया? All of you are
मैम ये
understanding?
दोबारा बता दो.
I am again saying from A you are going to B, from B you are coming to C, from C you are going to D, and from D you are going to E, E to F. This is the path that you have chosen. After reaching F, there is no way that there is no undiscovered node also, and there is no way that you can reach A. So you cannot form a Hamiltonian cycle from this path. You have reached a dead end. Clear हो रहा है? Yes or no?
Yes, ma'am.
So since this is not possible, so you will backtrack. Backtrack कहाँ से करोगे? अगर हम यहाँ पे नहीं जाए, E पे जाए, is there any other possibility from E? E से भी कोई और possibility नहीं है, क्योंकि B is already discovered. So you go back. Now you go to D. D से क्या possibility है? Instead of going to E, you could have gone from D to F. That means another possibility could be that you go from D to F and then you go from F to E. F से लेके फिर E तक जाएंगे. Now again you are stuck. No more unvisited nodes are left, and E to A again is not possible. So again this is a dead end. Are you understanding?
मैम पर F में E क्यों लेंगे हम?
बेटा अनविजिटेड नोड लेना है ना.
मैम बट अभी जब आपने पहले ग्राफ लेना स्टार्ट करवाया था तो आपने कहा था कि लेफ्ट साइड वाले E लेंगे और फिर राइट साइड वाला F लेंगे, उसमें E इंक्लूड नहीं करेंगे.
My mistake. So sorry.
जब आप बनाएंगे.
So my mistake, you are correct. Do not include this E, but then you cannot again reach a Hamiltonian cycle. Then you again cannot reach क्योंकि सारे nodes cover ही नहीं होंगे. Understanding? So this again is a dead end. So you backtrack. Do not include E. E has been considered here. D से E जाने का path is considered here. E will not be included here. Now you reach back C. Yes or no?
Yes, ma'am.
Now when you are reaching from C, just a second class. For this state space diagram, we are considering all the possible edges from all the possible roots. So if I am having A से B, B से C, C से D हो सकता है और फिर से उसकी सारी edges possible है. B can also be included here. B can also be included here. जो बिना B वाला state space diagram है, that we'll consider for the next example. इस example में for the current, there are two types of state space trees that we can draw. या तो दो तरीके के स्टेट स्पेस ट्रीज है. एक है जो आपका फिक्स्ड लेंथ आंसर है, उसमें क्या होता है यहाँ पे इंक्लूड करो और यहाँ पे एक्सक्लूड करो. सो इट बिकम्स 1 0, हर नोड पे 1 या 0, हर नोड पे इट इज अ 1 0 1 0, और जो आंसर आएगा वो 0 1 की फॉर्म में आएगा, वेदर यहाँ पे इंक्लूडेड है या नॉट इंक्लूडेड है. we are considering a different kind of a state space tree which is variable length. In that case we can explore all the possible paths. तो A से B के बाद A से अगर C पे गए then B also can be considered. Please rectify that. I am drawing the tree where I can consider B also. Currently I am moving on this path, so I am only taking this. F के बाद E could also have been gone, but it is also a dead end, so I backtrack. While backtracking, there are no more options available from F, so I backtrack to D. There are no more options available at D also now, so I backtrack to C. After backtracking to C, C से D पे जाने की जगह there was an option that I go from C to E, so I consider this option. I go from C to E. From E, I can either go to D or to F. Taking alphabetical order, I am going from E to D. Alphabetically चल रहे हम, so I am going from E to D. After going from E to D, I have only F is left, so I go from D to F. Again, I am reaching a dead end. There is no cycle possible, so I again need to backtrack. From going from D, I could have gone from D to A. D to A is a possibility. Now I could have gone from D to A, but then cycle is incomplete. F wala node miss ho gaya. So this is not a possible solution. So we will not be showing it in a graph. No other solution possible. Once again backtrack. I reach back at E. अब E से या तो D पे जा सकते हैं जो कि गलत पाथ था, या फिर F पे जा सकते हैं. So I consider going to F from E. After going from E to F, F से we can still reach D. So I go from F to D, and from F to D, D से A is again reachable. Now all the nodes are covered. I can reach back to A. So when I am reaching back to A, this gives me a possible solution. This is one of the possible Hamiltonian cycles available because I have reached back from source node A to A again, covering all the nodes in the graph just once. So this becomes the Hamiltonian cycle using backtracking. ये clear हुआ?
Yes,
Yes. There